Hello, students. Welcome back to our second day of notes and our final day of notes. And we don't have many notes to take today at all, but rather we're going to finish up our notes today. I'm going to show you some videos, and I also want to talk to you about tomorrow's lab activity. So if you recall from yesterday, we discussed yesterday 4 factors affecting the rate of chemical reactions. Do any of you remember what those 4 factors were? I hope you do. If you do not remember those 4 factors affecting the rate of reaction, go back in your notes from yesterday and review them. Review them to prepare for your weekly topic quiz. But without further ado, let us proceed with our notes for today, which have to do with energy of reactions. Yesterday, we talked about the factors affecting chemical reactions, and it is true that energy is involved in all chemical reactions. But today, we're focusing specifically on two things that can affect how the energy is either absorbed or released from a chemical reaction. So let's get to it. Energy of that's all, folks. Let's try that again. The energy of reactions in terms of the change of energy is what we're discussing here. Energy of reactions is based on the type of energy change taking place. And in particular, we are going to be measuring one form of energy. As you recall, earlier in the year, we talked about various types and forms of energy. It's one form of energy that we're interested in primarily here with chemical reactions. Let me explain what I mean. First, we have exothermic reactions. The prefix exo means out of something. Like the exit sign shows you how to get out of a room or a building. Exo means out of something. Thermic, as you recall, means heat, temperature, that type of energy. So the word exothermic literally means the heat energy that is released out of a chemical reaction. If I were to take a match right now and light it, which I'm not going to do because I'm in my basement and I'm literally sitting underneath a smoke detector, and I don't want to set off the smoke detector in my house and wake everybody up, because right now it's very late at night and I'm in the basement where nobody can hear me. But here's the deal. Lighting a match or an explosion, as you can probably imagine, release heat energy. It gets hotter. If something gets hotter, chances are it is an exothermic reaction. Again, exothermic, not to be confused with the 3 or the 4 types of chemical reactions that we've discussed in the past: the synthesis, decomposition, single and double replacement. These types of reactions we're talking about today are strictly referring to what happens to the change in energy. So exothermic can be any one of those other types of reactions, but exothermic is talking about the energy change in the reaction. So an exothermic reaction is one where heat energy is released, and you can observe that because it will get hotter. You could measure it with a device that measures heat energy called a thermometer. Okay, so this year in particular, you're all getting your temperature taken on your foreheads each morning, and it's measuring the heat energy released from your body. If your body is undergoing more chemical reactions or chemical reactions of a particular kind because of your immune system, your internal body temperature may be increased and you may become exothermic. And if you become more exothermic, hey, you might be running a fever and you might be sick, in which case you should stay home and not get the rest of us sick. So exothermic, releasing heat energy out of a reaction. So if we were to draw a diagram of an exothermic reaction, we could have our reactants, whatever they might be, undergoing the reaction, producing the products, and the energy is coming out of the reaction. This isn't a bad illustration of an exothermic reaction. Might be a good idea to add this to your notes if you haven't started doing it already. You got plenty of room in your notes there. But this is an exothermic reaction. Heat energy is released. That brings us to the second type of change in heat energy, and it's called an endothermic reaction. We as humans, we have an endoskeleton. Our endoskeleton is the skeleton on the inside of us. Endo means inside or into. So an endothermic reaction is a chemical reaction in which the heat energy is absorbed into a reaction. In other words, it gets colder on the outside because the heat energy is being taken in. Maybe this time of year, some of you like to bake cookies or cakes. I love baking. I love brownies and chocolate chip cookies and oatmeal raisin cookies and peanut butter cookies. Oh, I love cookies and I love cakes, especially chocolate cakes or vanilla cakes with chocolate icing. Oh, my mouth is watering because I love baking. Now, if any of you have ever baked, then you have done chemistry in your kitchen because baking involves mixing different chemicals together. It's those food ingredients, they're chemicals. You are mixing them together, but if you just mix them, then no chemical reaction takes place. You got to put them in an oven that you have preheated in order to speed up the rate of chemical reaction by increasing temperature. Remember yesterday. And usually you beat things together to increase surface area. Remember yesterday. And you add certain chemicals in your baking, let's say like baking soda or baking powder, which are catalysts to a chemical reaction. Baking is all about chemistry, folks. But here's the deal. Have any of you bakers out there ever noticed that once you put something in the oven, it causes the oven temperature to go down and the oven has to kick back on again to heat it up again to maintain a temperature in the oven? Have you ever noticed that? Now, there's a reason why. It's because those ingredients that you have put together, those chemicals that you have combined together, are undergoing a chemical reaction, and they are literally sucking the heat energy out of the oven to make the reaction take place. And because of that, if you want your cookies, brownies, cake, or whatever you're baking to come out correctly, then you've got to maintain a certain oven temperature for a certain period of time for that chemical reaction to come to completion. So baking is a great example of an endothermic reaction because it is sucking in or taking in heat energy from the surrounding area into the reaction that is taking place. Here's another example. Maybe some of you are involved in sports, and maybe you've gotten injured on the court or on the field, and your coach or somebody has a first aid kit nearby. And let's say you twist an ankle, you sprain your ankle. What's the first thing they reach for? One of those bags, those instant ice packs, right? And what do? They squeeze it together to pop a bag on the inside of that bag, shake it together, and then put it on your ankle, and it's like instant ice. It's cold. Well, how does that happen? Well, there are two chemicals on the inside of that instant ice pack bag. And when the bag on the inside is popped, those chemicals mix with one another and they shake it together, increasing the kinetic energy of the combining of those two chemicals. And a chemical reaction is taking place because it is absorbing heat energy from the surrounding area, and you detect that because it's cold. Or it's cold because you are detecting that reaction is absorbing the heat energy from the surrounding area. So whether you're in the kitchen or on the court, you have probably experienced chemistry and you've experienced endothermic reactions. Now, here's an illustration of an endothermic reaction, which is in contrast to the previous diagram I showed you. So check it out. Here we have the reactants, whatever they may be, undergoing a chemical reaction, producing products. But instead of the heat energy being released, the heat energy is being absorbed into the reaction, making it colder in the surrounding area. So again, I'd encourage you to copy this diagram into your notes to help you understand what is happening to the change in heat energy in exothermic compared and contrasted with endothermic reactions. Okay, so before you go on, make sure you review these two types of reactions, the endothermic reactions and the exothermic reactions. Now, I know this video is a bit brief here for today, but I'm going to be showing you some other videos today to illustrate some of these changes in energy that take place with the energy of reactions. And we'll be back tomorrow, and I'll explain to you in more detail our lab activity dealing with energy of reactions. So until then, you have a great day. And oh, wait, let me add one more thing. In the bottom page of your book, on the bottom of page 148, I've given you a couple of equations there. And what I'd like you to do is take some time right now to balance those two equations. And if you need to write them somewhere else so that you have more room, feel free. You got plenty of room on the bottom of page 149. But I would like you to continue by trying to balance those equations. Okay, so with that said, I'm going to say bye-bye.